Can you see the PPT now?
Yes, sir.
Yeah. So what we started in the previous class is the design of Cotter knuckle joints. These are all temporary joints where you can easily assemble and disassemble whenever as and when required. Okay. And the applications usually used in connecting a piston rod to the crosshead of a reciprocating engine and so on. And also while connecting the tractor to trailer, we can use a similar type of joint. And as I said, the Cotter joint is a temporary fastening and to connect rigidly to coaxial rods, which are subjected to axial tensile or compressive forces. And we know what a Cotter is. It's a flat wedge-shaped piece of cross section used between the socket and spigot connection, right? So Cotter joints transmit both tensile as well as compressive stresses. Yeah, and the taper is provided on both sides of the Cotter to facilitate holding of the rods by frictional grip. Okay, so excessive taper may cause slipping back of the Cotter, right? So 1:30 taper is recommended. Yeah, this is the Cotter joint assembly. This is socket. This is the Cotter, and this is the spigot, right? So socket holds spigot. That is, spigot will be sent inside while assembling, and then the Cotter will be hammered through the rods. Is that okay? Are you with me? Yeah. Are you there?
Yes, sir.
Yeah. So this is the socket which holds the spigot within it, and then between the socket, the spigot is driven into the socket, and through the common slot, the Cotter is pressed or it will be hammered down to ensure that the fastening happens. Is that okay? So basically, it consists of two rods. So the spigot is a solid rod, whereas socket is a hollow rod, right? So you have diameter here for socket. There is another diameter over there. Then you have got a slot. Then you have got a distance from the end of this to taper, Cotter end. Okay, when you consider spigot, we have one diameter here, collar over here, collar diameter, and another diameter is diameter of the rod. Is that okay? And then the gaps in between, then we have Cotter dimensions. Okay, and if you look at this, okay, if you look at this, the Cotter is subjected to pull in this direction and the pull in this direction, right? So therefore, it is subjected to shear, right? So that is what I have taken here. It's a Cotter joint where the Cotter is subjected to shear. These are all the dimensions. This is spigot and this is the socket, right? Socket holds the spigot. That is, spigot is driven into the socket, and then through common slot, the Cotter will be hammered down to facilitate for fastening. Is that okay? Are you there with me? Yeah. Could you
Yes, sir.
understand this? Yeah, could you understand this?
Yes,
Yes,
sir.
sir.
So the various dimensions of Cotter and spigot, socket and spigot type of Cotter joint, right? So now note down the sketch. So this is D2, this is A, this is E. This is E here, thickness of collar. All right. So D is the diameter of the solid rod. Okay. D is diameter of the solid rod. D1 is dia of spigot. D2 is dia of collar. This is collar over there. So this is collar. Please note down the sketch with all nomenclature. This is collar. This is thickness E. Thickness of collar E. And this is D2. Is the figure visible for you people? And when you come to the socket part, this is value C, which is thickness of socket collar. This is D4, which is diameter of socket collar. Okay. and then D2 is outside diameter of socket. There is a mismatch in the figure, so don't worry about that. B is the width of the Cotter and T is the thickness of the Cotter. Okay, that is when you take Cotter, B is width of Cotter, T is thickness of the Cotter. This is the value of H or T2. Please note down the terms T1 or E. They are the thickness of collar. Okay, so when you come here, it is T1 or E is thickness of collar. L1 or A is distance from end of slot to end of rod. F is the applied force here, right? So F is the applied force. This is diameter of the solid rod, right? D3 is the diameter of the, outside diameter of the socket, that is D3. D4 is dia of socket collar. I think it is more clear now, probably, correct? A or L1, E or T1, D2, D1, D4, D3 and D. F is the applied force. B is the Cotter width and T is the Cotter thickness. Please note down. Have you noted down the sketch? This is spigot, this is socket. So the spigot will be driven into the socket and then the Cotter will be hammered through the slot to ensure that the fastening happens. So if you want to remove the assembly, just hit this Cotter out, hammer the Cotter out, then you can have these two socket and spigot dismantled. Finished, huh? Sketch, have you finished? No response, I say. Note down these details. This is the spigot details, socket details.
So can you display the sketch 1 minute?
Yeah?
The sketch 1 minute, sir. Noting.
Yeah, that's why I ask whether you are completed. If not, you have to tell. Otherwise, how do I understand? Anyway, let me finish with this one. Done with this sketch?
Yes, sir.
Please note down the details over here. D is the diameter of solid rod of a socket here, right? D1 is dia of spigot. D2 is dia of collar. E is the thickness of collar, that is, this is the collar thickness. A is the distance from end of slot to end of the spigot rod, right? In socket, we have D3, that is outside diameter of socket. D4 is dia of socket collar. And C is the thickness of socket collar over here. H is the thickness of socket. Note down the terminology. Is it visible clearly, whatever I have written?
Yes, sir. The down portion is not very clear.
Yeah, it is thickness of Cotter. T is thickness of Cotter.
Okay.
While scanning itself, I have missed it out. B is width of Cotter. T is thickness of Cotter.
So the previous slide for 1 minute.
1 second. I'll take that. Just a minute.
Yes, sir.
1 second. Yeah. Okay.
Yes, sir.
Finished, huh?
1 minute. Yes, sir. Done.
Yeah. So now the job is to find out these parameters using proportions, okay, in a socket and spigot type of quarter joint. So first is to find out the diameter of solid rod. So that we can find out using the equation F is equal to pi d square by 4, that's area, into tensile stress. Next is to find D1T, okay? So that we can find out using the equation F is equal to D1T sigma C, where sigma C is the compressive stress. As we have learned in the previous discussion that the Cotter and socket and spigot type of Cotter joint is subjected to, or it will take up both tensile and compressive stresses. All right. But the Cotter is subjected to shear stress. All right. So that's why here while finding out D1T, use the equation of F is equal to D1T sigma C. All right. And then find out D1T. Right. That D1T we are going to substitute in this equation, the next equation, that is to find D1. I substitute D1T value here, and then I know the value of F. So D1 I can find out from the equation of tensile strength. Then to find diameter of the collar D2, use this equation, that is essentially force by area of cross section. That's all, because collar, you know, it is made out of hollow section, right? Hollow cylinder. So that is, you will have collar something like this. This is the collar. Okay, this is a collar. So when you have outside diameter and inner diameter for this, so therefore effective area is 4 by pi d2 square minus d1 square. That is, outside diameter is d2, inner diameter is d1. So while finding big collar is subjected to compressive stress, so therefore equate compressive stress is equal to load by area of cross section. So area of cross section of a collar is given by pi d square minus d2 square minus d1 square by 4, because it is a hollow section. Next is thickness of spigot collar. Thickness of spigot collar, we can find it out from using shear stress equation. From there we can extract the value of E, and then using shear stress equation again, I can find the value of A, outside diameter of the socket D3. Use this equation. All these equations are available in data handbook, so no need to remember these things. Then diameter of the socket collar D4, use the equation, because socket collar, again, it is T into D, that's the projected area is what we have to take. So from there we can get the value of D4. Is that okay? So please note down these equations into your notebook. Using these equations, we can find out the various parameters of the socket and spigot type of Cotter joint. Okay, note down this. T is thickness of Cotter. Please note down these equations. Using these equations sequentially, we find out all the required parameters of Cotter joint. Meantime, answer your roll call. 1,
Present, sir.
2, Abhishek GL, he was there, no, in the beginning. Okay. 3, 4, 5, 6, 7, 8,
Present, sir.
9, 10,
Present, sir.
11, 12,
Present, sir.
13, 14, 15, Darshan, 17, 18, 19,
Present, sir.
20,
Present, sir.
21, 22,
Present, sir.
23,
Yes, sir.
24, 25,
Present, sir.
26,
Present, sir.
27, 30, 31, 32, 33, 34,
Yes, sir.
35, 36,
Present.
36 present or what?
33, sir. 33.
33 Narendra, where were you? Say calling up.
Rating, sir.
36, 38, 39, 40,
Yes, sir.
41, 42,
Yes, sir.
43, 44,
Present, sir.
45, 46, 47,
Yes, sir.
48,
Yes, sir.
49, 50,
Yes, sir.
52,
Yes, sir.
53,
Yes, sir.
54, 55, 56,
Present, sir.
57, 58, 59, 60.
Sir,
Tarun?
his present mic is not working.
The three
Okay.
people have put their message on chat.
No, I'll see it later. 61, 62,
Yes, sir.
63, 65, 66,
Present, sir.
67, 'Chaitanya, Mahesh Madiwal.
Yes, sir.
Oh, Mahesh Madiwal, is there entry? Where were you for so long, I say? Huh? Mahesh. Is it Mahesh or somebody else called? Nishant? Ramesh? Shashank? Akshat?
Present, sir.
Sautrik Roy? Mahima Raj? Srivatsan?
Present, sir.
Suman Xavier? Madan Kumar? Manu Yeke? Shadab Khan? Ganesh R? Vijay Kumar?
Yes, sir.
Rishi S? Zahir Hussain? Yeah.
Sir, Vijay Kumar, sir.
Now Vijay Kumar taken. Right. So we'll go to knuckle joint now. Okay. So have you noted down these equations? Noted down?
Yes, sir.
Done.
Okay. Yeah. So next is the knuckle joint, right? So this is the schematic of whatever you want to call it as a knuckle joint, parts of a knuckle joint. So this is the knuckle pin, this is the collar, so through which a taper pin. So what we do is one eye end, and this is two eye end or fork end. To this fork, we are going to drive this fellow one eye and fork into that, and then the taper pin will be driven down, and then collar will be placed on through the hole that is present over here in collar and the pin, right? A taper pin will be pressed or hammered through to secure the joint. Is that okay? This is how a knuckle joint looks like. So what all the things that you have is fork end, then one eye end over here. So these parts, and then there is a pin, okay, which is again subjected to shear at two places. So it's subjected to double shear. Okay. So these are the parts, are the sectional view of that. And this is S1 here. This is the diameter of the rod. This is A. This is S. Again, diameter subjected to axial pull. C is the width of, diameter of the pin. Okay. And E is the height of the pin, right? So these are all the things. So, and what you have to do in knuckle joint assembly is, You'll be given with the force and so on. So just find out the diameter and then just calculate the remaining parameters based on the diameter. Is that okay? And the design of rod you'll have separately, and then we need to check for stresses. That's it. Okay. So that's all we need to do in knuckle joint. So please note down the sketch of knuckle joint, the sectional view of knuckle joint.
So can you show that the previous 3D this thing of knuckle?
Yeah.
Like this for Cotter joint, can you show it? Because I'm confused.
For Cotter joint,
That kind of a thing.
yeah,
What
this
is the
one.
difference, sir? I'm not able to differentiate.
Huh?
I'm not able to differentiate between the two, Cotter and knuckle joint.
Okay. What I'll do, I'll paste this fellow there. 1 second. Hmm? Can you see the difference now? Okay.
Yes.
Can you identify the difference?
Yes.
This is Cotter joint and this is the knuckle joint. All right.
So there's a hollow and this thing in Cotter
See,
joint.
here you have one single eye end, okay, fork. Here you have got double eye end fork. So this single eye end fork will be placed in between the gap here. Can you see the gap here? So this fellow will be pushed. That is, single eye end fellow will be pushed into the gap over here. So through the hole, that is concentric holes over here, this pin will be driven down. And then at the bottom, the collar and taper pin will be used for fastening. Is that okay? But in the sectional view, it is shown reverse. That's it. Okay. Here in Cotter joint, what you have is you have one rod. Okay. You have one rod and you have one socket. Okay. So you have a socket like this. Okay. So now through the socket and spigot, this Cotter will be hammered into. But whereas here we have a pin for which we are going to have a collar and taper pin to lock it. Is that okay?
Okay.
Got the clarity now?
Yes, but there's a slot even in Cotter, no sir, for the in Cotter joint for the Cotter to go. There's a slot in the.
Yeah, there will be a slot. There will be a slot, and Cotter is a taper one. So keep hammering down till it gets locked. That's it.
Okay.
Right? But here we have a pin which will be closely machined, and then we'll use collar and taper pin to lock it. Here the taper will be used for locking. Here we are going to use a taper pin here and a collar and taper pin to lock the assembly. That's it. So if you want to remove the assembly, remove this taper pin out, collar will fall down, then the pin will be taken out, and then the single eye end, two eye end can be separated.
The socket and spigot for both the joints will be similar, sir.
For which joint? This is Cotter joint. Using Cotter joint is secured. This is knuckle joint where we use knuckle pin to secure the joint. That's it.
Okay.
Construction of both are totally different.
Okay.
Okay. Yeah. Yeah. Please note down this sectional view of knuckle joint. Make it fast. Finished, huh? Finish noting down the sketch.
1 minute, sir.
Yeah. Finished, huh?
Yes, sir.
Okay. Anyway, we'll continue in the next class.